sediment when it gets in the river. This one's super easy. This is probably the easiest one in the entire list. It's all about aquatic vegetation, what we call macrophytes, rooted aquatic plants. We've known about this for decades and decades and decades, going back to the 90s. A lot of research done. Right this time of year, you got this aquatic vegetation that's just starting to grow. But in 3 or 4 weeks, it's going to be really dense, and it just acts like a big filter, and it just traps all the fine sediment that comes out of Island Park Dam. So you got sediment coming out of the reservoir, gets trapped by the plants, it just sits there from, Box Canyon all the way to Riverside in aquatic vegetation. The plants are there from July through February, and as long as they're there, they're just going to keep trapping sediment. The only way to get that stuff out of there is to scour it when the plants aren't there, which is March, April, May, and June. You got a pretty narrow window on that. Here's a couple photos. These photos were taken at the exact same spot in the river. I know that because it was a monitoring location we used for Zach Kuzner's master's thesis, and we had a picture from it in September. I said, go back in April and take the same picture, and we did. And so here's what it looks like at the peak of plant growth. Underneath that, you can see when the plants are gone, you can see some gravel in there, right? There's some nice clean gravel, but you can see it's mostly embedded in a bunch of fine sediment. So the way to move that stuff out of there is to deliver what we call a freshet, or a springtime flushing flow, or a peak flow, or something during the springtime. I mentioned March through June. Because of other constraints like snow and ice and filling the reservoir and water rights and a bunch of other stuff, turns out that April's about the optimal time to do it. It's really hard to do it in those other months. So this year, it just turned out we had the opportunity to run a freshet flow. We haven't had one since 2020. And this year's, we actually had accumulated a lot more data since the last time we did this. So I was able to actually design the flow rate, the ramp up, the ramp down, the timing, the day, everything, present it to the Drought Management Planning Committee. The science was so solid, and it fit within the Upper Snake River Basin Management Scheme that needed to happen at that time, that Reclamation said great, Fremont Madison said great, everybody else said great, let's do it. So we did it. And 6 hours after the peak flow was reached at the dam, this is what the river looked like at Pine Haven. Glad most of you weren't here to see that. But 75 turbidity units, that was the highest we've ever recorded in the 9 years of our, by a long shot. Like I think our record was 25 or something, and we got 75. And so again, compare that to the summertime. So there's 8 or 10. Here's what 75 looks like. But look at the bottom right photo. That was what the dam looked like only 4 hours after hitting peak flow. And that was with almost all of the 2,000 CFS out of the gate side. So there was about 300 on the power plant, and what's the rest, 1,700 out of the gate. There hasn't been that much outflow out of the gate since 2011. Okay, and it was crystal clear. Turbidity was like 4. We were astounded. We did this just like, well, wait a minute. So what does this tell? Well, and I should say that the reservoir level at that time it wasn't full, it wasn't even close to full at the time. And it was drawing down as fast as it does in the summer. It was drafting at over 1,000 acre-feet a day, which is a high draft rate, and yet the outflow is perfectly clear. So that tells us that there's not a whole bunch of sediment just sitting there behind the dam waiting to be exported as soon as somebody opens the gates. We opened them, we got nothing out of the reservoir. There was a little pulse of sediment that lasted about 2 hours. It was phenomenal. So that's evidence, a lot of evidence, that the turbidity and the sediment we see in the summer is not coming from the river channel, it's not coming from the bottom of the reservoir, it's coming from the west end via these weather and wave actions. So we learned way more from this freshet than we could have imagined, but we only learned it because we were able to come to the Drought Management Planning Committee with a very highly specified plan so that I could have my staff out there monitoring it at the exact times we needed to, both instrument and field samples to validate the instrumented samples. So that's about as good as it gets. And I don't know any conservation group anywhere that hasn't, that's able to do something like this. I mean, this is phenomenal.